Hello all, I welcome you for the lecture series. Uh, the course is Engineering Materials and today we are going to discuss about Charpy and ISAC test. So what is the basic property that is behind this material property testing? It is all about toughness. So toughness is the ability of the material to resist or withstand deformation under shock load. So we usually in the classrooms we explain this with an analogy, right? A person calling a person or a student to stand in front of the class and suddenly giving a blow in his hand, just a blow for demo. Okay, so the person stops moving from one point to another point, resisting the impact load. That is how we explain things in class. That is for fun, and we have a real testing equipment for the same impact test here. So this is based on their names who have invented Charpy and Isoid. We have a test set up here which is shown in the figure. So we have a base and this is the position of the specimen, and we have a position of the pendulum before hitting the specimen, position of the pendulum after hitting the specimen, and recording scale. So basically what mechanism this test is working is we have to raise this pendulum to a height where the potential energy is being gained and the potential energy is suddenly released so that the pendulum rocks from left to right, or it is getting a to and fro motion, hitting the specimen with a blow. This blow is nothing but the beautiful word called impact. So for this test, how we are going to prepare a specimen, we see in the next slide. So basically we have two tests. One is Charpy test and the other one is isoid test. So Charpy test, we have an impact load that is being applied. We have to prepare a V notch. And isoid test, we can either prepare U notch or V notch. The position of the specimen which is kept in the magazine is like this. In Charpy tests, it is kept horizontal. In isoid test, it is kept in the vertical position. Okay. So now we can see this Charpy tests where the flow goes like this. First one is specimen preparation. A rectangular or V-notched specimen is prepared from the material of interest according to specific standards. The specimen dimensions and notch geometry are specified in the testing standards as we use American Society for Testing and Materials. So the test setup is the next point where the isoid testing machine is prepared, consisting of a pendulum with a striking edge, a clamping system to hold the specimen, and measuring system to record the energy absorbed during impact. So next comes the specimen clamping. The specimen is securely clamped in a vertical position using specified clamping system. The notch of the specimen should faces the pendulum. That is very important. If you keep the notch opposite side of the pendulum, then you are doing a wrong impact test and it will damage the system usually. So it should be very careful where the notch of the specimen faces the pendulum. The next point is pendulum release and impact. The pendulum is released from a specific height, swinging freely towards the clamping specimen. The striking edge of the pendulum strikes the specimen at a position of the notch, causing it to fracture. Then comes the energy measurements. Upon the impact, the pendulum transfers a portion of its energy to fracture the specimen. The energy absorbed or lost during impact is measured using the system that records the pendulum swing height after the impact. So the difference in swing height before and after the impact provides an indication of the energy observed. Calculation of the impact energy is by considering the difference in potential energy of the pendulum before and after impact. The test is usually repeated multiple times with different specimens from the same material, and the average value is obtained. So the eyesight test measures the material resistance to fracture under a high-speed impact. It provides valuable information about the material toughness, brittleness, and ability to withstand sudden impact or shocks. So we have a beautiful comparison here. So where the RP impact test and eyesight impact test, what are the materials used, how the notches to be done, and the specimen striking point, common specimen dimensions, and common specifications. ASTM E23 is used for choppy impact test, and ASTM D256 is used for eyesight impact test. So whenever we take these students to the lab for this test, they will be everyone will be amazed by seeing the rocking speed of this arm, which is in the Charpy and impact tests. So the dimensions of the specimen is given here 55 into 10 into 10 mm, that is length, breadth, and thickness, and there is a small V notch which is being used. So initially we said the notches to be done. Eyesight impact tests we should do only V notch, and Charpy U notch and V notch can be used. And this is all about rock eyesight and Charpy tests. Thank you all. Save trees, save nature.